You should be on your trig unit here. I'm going to get you to move down to your page 2. Just loading up my stuff on this side. Let's get started. Perfect. All right, so you've seen this before, the Pythagorean theorem. This is going to end up you're using this a little bit sometimes as well, but just as a really quick reminder here. So the Pythagorean theorem, Pythagoras, that's using two sides of a triangle to find the third side, right? If you're trying to find the length of one of the sides of a triangle and you have 2 of the 3 of them, you can use that to always figure out the third as long as it's a right triangle. So that's what Pythagorean theorem is. But most of what we're going to be doing today is going to be you're gonna hear this repeated 1,000 times. Has anyone seen this before or heard this before? SOHCAHTOA? No? You will repeat it enough times that it is like glued into your brain at some point. So we've seen one of these words before. We've seen this tangent before, or TAN. Do anyone remember, what did we use that for?
To find the hypotenuse.
Ooh, not quite. That's the Pythagorean theorem, but it does involve triangles. The angle, yeah. So we use this to find the angle. So you might recognize that, you might recognize this SIN. It's not sin, it's actually sine is how you technically say it. But that's on our calculator. The COS, cos, that's on our calculator. The tangent, tan, that's on our calculator. So we've seen the tangent at least before. And you're right, we use these to find angles. Or not necessarily to find angles, we use them. So we use trig. That's what this is. That's what those 3 things are. So I'm just going to put trig. We use trig to whenever angles and right triangles are involved. You can use trig to find angles. That's primarily what we've done. Sometimes you can use it to find the lengths of sides as well, actually. But you only use it when angles themselves are involved. And Hannah, you're able to see okay? Feel free to just type in chat if you want to as well.
Yeah, I can see.
Perfect. Okay, so something else we've seen before. So first off, this little symbol right here, I'm circling red. You don't have to circle it. That circle, that symbol is called technically theta. So when I say theta, that's what I mean. This is also means it's the angle. Theta. I think I called it sigma one day. I'm like, wait, why did I call it that? I never just corrected myself. Sigma's a different math thing, but yeah, this is called theta. It means it's the angle, right? So you can see this, that means it's an angle. And then whenever we're trying to label a side, this is when Pythagoras comes into play. We know that, so there's 3 sides of a triangle, right? The hypotenuse is always going to be opposite of that right angle. And then there's two things left. There's opposite and adjacent. The opposite side is always going to be the one that's opposite of the angle that you're given of theta, which means if you know what the hypotenuse is, you know what the opposite is, you know you're just going to have adjacent left here. So that's how we find the sides of all the triangles. We'll do that in a second. But I want to go into this thing here first. So this SOHCAHTOA thing, hugely important. You are going to, this is going to be engraved into your brain. There's like two things people graduate with. One is SOHCAHTOA. It's like, it's there forever. So this means something. This is a kind of like a cheat code in order to try and figure out some math stuff. So we're gonna write this down really quickly. But so this SOHCAHTOA, so SOH, what this actually means is sine is opposite over hypotenuse, right? So it's in this order for a very specific reason. So sine, is everyone able to see okay? Bracket, theta bracket, you're able to see? Yeah? Okay, perfect. So sine bracket theta bracket is equal to, so that's the S. The O is going to be opposite. I'm just going to put OPP. The H means hypotenuse. So if we want to find the sine of the angle, we need to use opposite and hypotenuse here. Sorry? What was the question? Oh, it wasn't a question. It wasn't a question. It was just a statement. We use so SOH, so means sine is equal to opposite over hypotenuse. So we see where I get those letters from here. So first letter of each thing here. Okay, and so the next one here, so CAH. So and then there's CAH. This is going to be cos. That's where that C comes from, of the angle of theta. So bracket, theta bracket is going to be equal to, there's an A here, right? So that means it's going to be adjacent. So A, D, J, all over hypotenuse, H, Y, P. That's where the H comes from there. And then finally, of course, so there's ka, and then there's toa. This is the one we were more familiar with. This is tangent. Sorry, so I'll just put toa there. So this is tangent. We've seen this before. We saw this 2 units ago. Tangent of the angle of theta is equal to O is opposite all over adjacent. Okay. Cool. So we have that down. But what does that actually mean? Well, that's what we're going to end up learning. And so for this, oh, what did I do with that? Sorry, I need to throw something in here 1 second. Put you there. And let's open you up on here. There we go. So we're going to practice a little bit. I actually printed these off for you. So I hope that's legible. I did that all freehand on my computer, so it's not super neat, but you should see something like this. So in order to be able to solve these types of questions, so this thing here, so this the first thing saying, find the sine of theta. This is the fancy way of saying, find what this angle is. Whether it's, whether it's 20 degrees, 50 degrees, 80 degrees, we don't know, but that's what it's asking you, is to find this angle right here. Let me make that bigger. So if I want to do that, there's a couple things I need to do. The first thing is I need to figure out what side is what. So I'm just going to say this one over here is I'm just gonna say it's X because it's a blank one. So Austin, which one of these do you think is the hypotenuse? The 5, the 8, or the X? The 8, right? Because this one's gonna be, I'm gonna put a little H here, right? This is the hypotenuse because it's opposite of the right angle. Jocelyn, which one is either the 5 or the X? Which one of those is gonna be the opposite side? The 5, yeah. So I'm gonna put a little O there, which means this has to be the adjacent side here. Cool. So I figured out what side is what on the triangle. And now if I want to try and find the sine of this, well, if I'm finding sine, again, you're thinking about it, you're thinking like SOHCAHTOA up here, make that bigger. If you're thinking this thing right here, SOHCAHTOA, if I'm finding sine, oh, I know that sine of the angle of theta is equal to opposite, I'm going to put an O, over hypotenuse. Cool. So I figured out my formula. Now all I need to do is I need to substitute stuff in. So sine of my angle of theta. What's my opposite? Yeah, you betcha. 5 over 8 is equal to 5 over 8. Like the degree? Oh, it doesn't do that actually. Well, at least it not the way we're thinking. Like it doesn't know that you're doing it like with degrees. I guess is one way of putting it. So if I have my calculator here, so I know I need to do sine of theta is equal to 5 over 8. I'm trying to figure out what this angle is going to be. I'm just going to take sine. Let's see what this spits at me. 5 over 8. That's not going to work. This is not an angle of 0.01 degrees. Sorry? You're absolutely correct there, Kim. So I don't care what sine of the angle is. What am I trying to find here? The angle. So I want the angle all by itself here, right? So what I need to actually do is I need to divide by the sine. But remember when we tried that the one day, it just broke the calculator? So you're right, Kim. We need to actually do this. We need to take the second function, top left button, of sine, and then we're going to put that angle in there. So of 5 over 8. So now it's going to spit me out a more appropriate number, which is 38.68. So 38.68 degrees because it's an angle. So the reason we use that second function is because that's technically dividing by sine here, right? And we can't do that naturally on our calculator. So it's kind of like it's your calculator's cheat code. It doesn't know how to do it otherwise. It has to be that second function key. Sorry? This one? For number 2? Oh, for number 1? So yeah, so the angle here is going to be 38.6. Oh, I see what you're saying. So it's not going to be the adjacent side. It's actually going to be just the angle here. So that's what this angle is. Yeah, so if you were to take your protractor, put it up on there, that's the angle you'd get. So try question 2 out for yourselves. I'm going to give you 1 minute. Try out question 2. You set it up the same way. You're still trying to find that sine of it. The first thing you got to do is label each side. Figure out what's what. Okay, so which of my sides here is the hypotenuse of triangle number two? Which one of these sides is the hypotenuse? Five, you betcha. Because that one's opposite of that little right angle here, right? That right angle is that little square here. I know it's not a very neat triangle. What's my two going to be? Oh, but which side is it? It's opposite, right? It's because it's the opposite thing of our angle that was given to us, which means this is our adjacent. Cool. So I know I need to find sine of this because it tells you. So sine of theta is opposite over hypotenuse. So it's going to be the 2 over the 5, right? Because that's the opposite. That's the hypotenuse. So 2 over 5. And now what do I do? And how'd you get that? Yeah, yeah, so you took that inverse of sine, you did that second function of it, and then you just put that fraction in there, right? So that second function, sine, and then 2 over 5, you get 23.58 degrees. Cool. Is that making some sense? So for question 3 here, it's asking to find the cos of this. Does anyone remember off SOHCAHTOA, what is that equal to? Fill this in for me. Yeah, so cosine of theta is equal to what over what? Adjacent? Yeah, over hypotenuse, right? Because there's the c here, that's cosine, is equal to a adjacent over hypotenuse. It goes from left to right there in order. Cool. Yeah, it's all measuring degrees. There's just different types of doing it, different ways of doing it.
I think that's an answer for when I did the sign.
Ooh. It's possible. Yeah, depending on what the sides are, it's actually possible. Okay, so if cosine is equal to cosine of theta is equal to adjacent over hypotenuse, what's my adjacent side here?
Adjacent?
Yeah, is it 3, 4, or 5? It is 3, right? Because this, you betcha. And then what's my hypotenuse here? 5. Cool. So cosine of theta is equal to 3 over 5. And if you punch that in your calculator, second function, cosine. Now, someone tell me, why am I using that second function here? Why am I just not pressing cos regularly? It's important to understand this distinction.
Because it's dividing and reciprocate.
Yeah, because I'm trying to divide. Technically what I'm trying to do is I'm trying to get rid of this cosine thing here. So I'm just left with the angle. And so this is your calculator cheat code for that. Yeah, so good job, Kim. Yeah, so I take that. So second function cos of 3 over 5. That's going to give me my angle, which is 53.13 degrees. 53.13 degrees. Okay. Chat. So try out number 4. I'm going to just spit out the answer in a minute, so give that one a go. Ooh, so how'd you get that? So you did, so cosine of that is 12 over 9. So you're saying the adjacent's 12. You're right. So technically it would be over C here. So that's the reason you got your error there. But there's no like C button on here, right? So now we have two things we don't know. We don't know the angle, we don't know the C. You can't have an equation when you have two things you don't know. There can only be one thing left over. So, but we do know how to find C, don't we?
In the hypotenuse.
Yeah, we know how to, this is the hypotenuse here.
So is it tangent over 12, 9 over 12?
I see what you're saying. So I like where your head's going there. Well, I do know two sides of a triangle. And so I could just, instead of using cosine, I could use, I have opposite and I have adjacent, opposite, adjacent. Oh, I have tangent. You could do it that way. I'm just gonna say, that's correct. You get the right answer that way. I'm not gonna do it in this case because I wanted to just demo, like give a quick reminder of Pythagoras, because technically I could just figure out what C is as well. But your way would work, Kim. Okay. So I do know that if I'm trying to find the third side of a triangle, I'm trying to figure out what C is, because I need C for to find the cosine of it. I know that I can just take, if I have two sides of a triangle, I can just use Pythagoras, which is a squared plus b squared is equal to c squared to figure that out. What's my c squared here?
9. Oops. B squared?
Yeah.
It would equal what those are. It would be 9 times 9 plus 12 times 12 equals.
Oh, I see what you're saying. So, sorry, let me clarify. Which side is my c?
That's
This side here, right? Yeah, it's the hypotenuse here. It's the one I don't know. So I'm gonna leave that how it is. And then you're right, Kim. Then I'm just gonna take, okay, well, I'm just gonna say 9 is gonna be A. It doesn't matter as long as I have the hypotenuse.
81 plus what? I think it's 144.
Yeah, so it'd be 81 plus 144. You could plug it all in your calculator like this as well. So I could just do 9 squared. Again, just a refresher on Pythagoras. 9 squared plus 12 squared. It's gonna give me 225 is equal to c squared. But I'm not done, right? Because I don't care.
225 squared.
Yeah, you're right. I need to take the square root, right? Because I don't care what c squared is. I care what c is. So I'm going to take the square root of that. So take the square root of 225, 15. Yeah, so now I know that c up here is 15. Yeah, so and then so I'm going back to my original equation up here. Oh, erase. And you bet, I'm gonna, instead of c, I'm gonna put 15 up there. And now I know how to solve this. So let's take a look at that then. So, oops. Second function of cos. Oops. I'm going to be honest with you. If that's the same answer, it was not intentional. But sometimes that can happen. Like there's a 36 point. Oh, you did sine. Oh, okay. Yeah. So if I take the inverse of this, that cos thing here. So the inverse of cos of 12 over 15. That's going to be my angle. That's going to be what I put there, 36.87. Yeah, degrees. Yeah. Cool. So is that making some sense on how we can like solve this? If we're trying to find an angle, we just need to figure out what side's what on the triangle and then do it. Is that making some sense there? Where it gets a little bit trickier is when we scroll down to, sorry, does everyone have that? Okay. Where it gets a little bit trickier for people tends to be with this. So what's different about these two questions is before I told you find sine, find cos, find tangent, whatever. In this case, it doesn't tell you that, does it? So what we need to try and do now is we need to figure out, well, which ones do I use? So we're still gonna do the exact same first step, which is label the triangle though, right? So I know that this over here is gonna be my hypotenuse, right? This blank side, I don't know what it is. The 7 is gonna be my opposite because it's opposite of this angle, right? So this is my opposite, which means that the 5 has to be the adjacent. So what two sides do I have something for?
The adjacent and opposite.
Yeah, I have that. So I have adjacent and I have opposite, right? So so this is where SOHCAHTOA comes in. So I'm going to scroll all the way up For SOHCAHTOA, which one of these has adjacent and opposite? Tangent, right? Tangent has adjacent and opposite, so I need to use tangent here. You betcha. So let's put that in. So I'm trying to, I know I need to use tangent because I have an opposite and I have adjacent, SOHCAHTOA. Yeah, so tangent of theta is equal to opposite over adjacent, right? Over A. Now I just substitute it in. So I don't write that fast with this, so but you're right. Opposite over adjacent is going to be 7/5. And then I just take that inverse of it, right? Because now I'm trying to just get this little angle all by itself, get the theta all by itself.
Would it be 5/7?
No, it would be 7/5 because it's TOA, right? So it's the opposite over the adjacent.
Oh, okay.
Yeah, yeah. Okay, and if I eventually do that, I get my angle, which is 54.46 degrees. Cool. So I want you to try out that last one there by yourself. You have to label the side, then you have to figure out which trig function can I use. Is it sine? Is it cos? Is it tangent? You're thinking sine? S-I-N? So you're thinking sine, and why are you thinking sine? Yeah, because so we only have the O and the H, which means it has to be sine, you betcha. So it'd be sine of theta is equal to opposite over hypotenuse. Oh, what'd you get? 24.6? 24.462? Oh, 0.6. Okay, thank you. That sounds right. And if you ever end up with like a 0.00 something, you know you didn't take the inverse of it. You didn't do that second function. Okay. So is that making some kind of sense then on how to like identify the triangle? So it's figuring out which equation we use and then substituting it in. And that's going to tell us our angle. Okay. So I just wanted to do like a quick thing about that. So once you have that in, we're going to go back to our other booklet. So we're going to go back to our other booklet now, and we're going to head to that third page. Third page, you betcha.
So be an adult. Do you have to go
Sorry? Like what?
Just
what-
looking at something to keep BTS out of school management.
Oh yeah, in are they Korea?
Yeah.
Yeah, Korea. Everyone has to do mandatory military service. Yeah, for up to 20 months, I think.
18 and so it's mandatory.
Oh, is it 18? Okay. I might be thinking of a different. A lot of countries in Asia do that. A lot. China does.
Number 3. Oops,
Oh, sorry.
number 3.
Page 3. Page 3. On the big booklet. So page 3 on the big booklet. Okay. So first off, again, so we're armed now with two things. We're armed with the ability to find angles, SOHCAHTOA, and we're armed with the ability to find missing sides. So the first thing you always need to ask yourself, whenever you see a right triangle, what is it asking me to do? That we have so many formulas now.
Solve the triangles.
So solve the triangles. What's it trying to tell you to find here though?
There's only one triangle.
There's only, yeah, there is. I think I deleted it. Oh no, I do have B on the second page.
Oh, okay, so we have to find the hypotenuse, which would be, so we have to 7.5, or we do that square?
So I like where your head's going. So this is, there's no, we don't see a theta in here anywhere, right? There's no theta. So when it says, it's telling us to solve this, the only thing that's really missing is our hypotenuse here. So I need to find the hypotenuse.
The square?
So I need to use Pythagoras. Yeah, you're right. So the first thing you always need to figure out is, what is it asking me to do? Because now we have a lot of formulas. We need to know which one to use. So it's asking us in this case to find the hypotenuse. And to find that hypotenuse, we have two sides. So we have two sides of a triangle, which means we can always find the third side.
15.3, right?
So before I even go into what A is, I want to know what C is going to be. C is always the hypotenuse, which is blank in this case. So I'm going to leave that how it is, because that'll come into play later. So you're right. And then it's A squared plus B squared. It doesn't matter which one of these goes wherever. Yeah. So you could put 7.5 as A if you wanted. It's not going to change the answer if you put it for B as well. So as long as you have the hypotenuse properly labeled. Cool. So 7.5 squared plus 15.3 squared is equal to C squared. So I'm just going to punch that all in my calculator here. 7.5, that little X with a little 2 above it is the squared button. Plus 15.3, I'm going to square that.
So I don't know if I did that right. Can I just press square after I get the 290?
Okay, yeah, I wanted to bring that up, yeah. So let's take a look here. So I know I need to take the square root of this, right? Because that's gonna fix both of these. Just give me what C is, what my hypotenuse is here. So to answer your question, Kim, if your calculator looks like this, this thing on the bottom right, your calculator remembers what that is. You can just take square root and press equals there, and it's gonna plug your answer in there. That will work. Yeah. Otherwise, though, let's say, for example, so first I'm just gonna write that answer in 17.04 centimeters. So that will work, Kim. What will not work, though, is let's say, for example, like sometimes you're like me, I press this by accident. Oh, whoops, I wiped my answer. I see that it's 290.34. You can't just take 290.34 and then take the square root. That's going to break it. So if you accidentally cleared it, because this little C here means actually clear, you'd have to put the square root first. But if you just did it how you did, you can just press square root equals. That will work too. Yeah. Sorry? For like number one?
So we have the hypotenuse. We still get the same answer with the same formula.
Oh, this one here. Oh, so this is why I said we got to figure out what C is first. So I like where your heads are going with this. So first off, there's no theta in here. We're trying to find the missing side in this case. And so I know I have two sides. I can use two sides of a triangle to find a third one. I know I need to use Pythagoras. So this is on our next page. So I like where you guys' heads were going with this.
Okay.
So now I have my formula. Now I'm going to substitute in, right? What's my C in this case? It's the hypotenuse. 9.3. Yes. So this is where this is different. because this is my hypotenuse. This is my C over here. That all hypotenuse always goes over there. So we've never dealt with something like this before. So now I'm gonna keep substituted in. So I have 4.3. I'm just gonna put it as A because I've labeled my hypotenuse. Doesn't matter where it goes now. So I'm just gonna put, instead of A, I'm gonna put 4.3 squared. And then in between is just B squared, right? This line right here, the missing side, this is technically what B is. Yeah, no worries. I'll dig it up. Okay. So you guys recognize that this is weird. But we're still going to solve it the same way. We're still going to solve it the same way, just with one extra step. So first off, let's square this stuff out. So 4.3 squared is going to give me 4.3 squared, 18.49. I can do nothing with B squared, so I'm just going to bring it down. Plus B squared is equal to 9.3 squared, which is going to give me 86.49. I just want to bring up this sheet here. Hannah, I think you're going to have this sheet I'll bring up in a second too. Bear with me 1 second. This one? This one. So you guys have this sheet here, right? Except I put all of yours on one page. This thing here. Oh, I lied. I did not print all 4 copies. That's okay. Just a quick refresher. Yeah, I lied. Sorry, guys. We'll have to make do. But I wanted to specifically go to one part of this. I wanted to go to this thing here. So when we looked at this a couple of weeks ago, this is what this is. This is Pythagoras theorem. We have a right angle triangle. A squared plus B squared equals C squared. If you were to add all these up, there's 9 blocks here. Plus there's 16 blocks here, gives us 25. And there's a total of 25 blocks in our C squared here. So now what we have is we need to take our A squared. If I didn't have any of this, if I didn't have B squared here, I didn't know what B was, I could figure it out by taking these 9 blocks away from C squared. How many blocks do I have left? Except, how many blocks do I have in C squared, except for the ones I'm filling in? 16. There's 16 down here, isn't there? So that's kind of like how this works. So what we're actually going to do is we're going to take C squared. We're going to subtract A squared from it, right? That gives us what B squared is, right? That's just what we did. 25 minus 9 gives me 16. Same concept, harder numbers. So what I need to do is I need to figure out I need to get B by itself, don't I? That's the ultimate goal I need to do here. So what I'm technically doing is 86.49, and I'm subtracting this 18.49. Oh, I'll get there. So what I technically did on both sides was I took away 18.49, right? On both sides. I don't have space to do it over here, but I did that over here too. These cancel each other out, and then I'm just left with 86.49 minus 18.49. So B squared gives me, oh, Jasmine, 68. And now, am I done? No, because I don't care what B squared is. I care what B is. That's the length of the triangle, right? So what do I need to do? Not square, take the square root. Yeah. So I take my square root of 68, and that's going to give me my answer now. So now that tells me what B is. B is equal to, I'm sorry, what was it? 8.25 millimeters. Okay. Everyone good there? I know I'm throwing a lot at you guys really fast, so. What do I want to do here? Okay. I remember what I want to do now. I want you guys to take this time before we keep moving forward because it's going to get a little bit more complex now. We have all the stuff we need at this point, but you can make some really mean questions with it. In fact, like, so what we just learned is like the bread and butter of like carpentry. You need that stuff to be a carpenter. If you're working with any type of like construction material, huge. So what I want you to do is I want you to go to page 8 and I'm going to give you like 10 minutes or so, 5 to 10 minutes to work on these 4 questions that we have here. And the first thing you need to do before anything else is you need to ask yourself, what is it asking me to do? And what do I have to work with? Because that's going to tell you which one of those many formulas we have now to use. Just as a way to kind of test your answer. So for this first one here, it tells you right away you need to find tangent. I know that this is my hypotenuse, my blank side. This 7.9 is opposite of my angle, so this is my opposite side. And then that means this 12.3 has to be adjacent. So I'm going to take tangent of theta, which means it's going to be opposite over adjacent. My opposite is 7.9. Sorry, tangent of theta, put that in there. So my opposite is 7.9 and my adjacent is 12.3. So what I'm doing with this calculator here, Hannah, is what I technically need to do is I need to get rid of this tangent because I don't care what tangent of the angle is. I just want to know what the angle is. So if I try and take if I take this fraction, if I take 7.9 over 12.3, that's the fraction on top. And if I divide that whole thing by tangent, it's going to break my calculator. Doesn't work. Doesn't know how to do it. So what I actually need to do is there's a certain cheat code on our calculator. So instead of dividing by tangent, if we press this second function button on the top left, are you able to find that on yours?
Yep.
Perfect. So if you find that, then you're going to press tangent and you're going to get something that looks like this. Tangent with a little -1 on it. That means the inverse of it. That technically means dividing by tangent. That's your calculator's cheat code. And then you're going to put that fraction in there. So then you put that 7.9. Ooh. 7.9 over 12.3 in here. So you should have that tangent to the power of -1. Then you have your fraction. And so if you have that, you press enter, what do you get?
What do I do after I press tangent?
Oh, so you do second function and then tangent, and then you're gonna press that little fraction button, that little A/B.
Okay. And then equals. Right?
And that's going to be, and then equals, and you should get this. Did you get that?
Yep.
Perfect.
Yep.
So you know the angle is going to be 32.71 degrees there. That makes sense?
Yeah.
Cool. Is this practice? Oh, sorry. This is not a concept check. I just accidentally had breathe in my finger. So I'm just gonna hand out the answer keys for these because these are technically practices. So you guys can check your answers here. This is also available on the computer. If you wanted, I figured I'd put mine off this time. So I think, Hannah, you should have an answer key as well. It should be your green piece of paper.
Yeah.
only look at it after you complete the question. It doesn't like, it's okay if you get this wrong. We use the answer key to figure out like, to try and help out like what went wrong with it. If you finish all these, you can check your grades, or not your grades, you can check your answers for part 1, question 1, A, B, and C. I'm going to give you 2 more minutes to finish those ones up. So I'm not actually going to go through and work at each one of these unless someone asks me. It's okay to ask me, how did you get that? But if you're not asking me, I'm assuming you got it right.
Okay.
Did you finish? You got the all part 1 right?
Yeah.
Okay, I'm assuming everyone's good there. For this one, you got this right. This is where you had to do Pythagoras. Is everyone good for these? Oh, okay, yeah. So everyone try question 2 then if you haven't yet. You will get time to come back and do this stuff. You will get time for that. I just wanted to give you time to practice now before we move on to a bit of a harder question. For number 2. So what? So first thing we need to ask yourself is, what is it asking us to do here? Finding the height, right? So okay, so I'm trying to find a length of a side, and then what does the triangle give me to do that? What do I know about this triangle? Do I know any sides, any angles? Yeah, so I know the hypotenuse, and what else do I know? I know another side, right? So I know I have two sides, and I'm trying to find the third side. So which formula do you think I'm going to use there? Pythagoras, you betcha. So a squared plus b squared is equal to c squared. One of the hardest parts is when people trying to figure out what do I actually need to do. They know how to do the math. It's when they have to try and figure out which formula to use that it tends to get a little bit more difficult. So I know I need to use Pythagoras here because I have two sides of a triangle and I'm trying to find a third one. So that's the first thing. So what's going to be my c squared here? 19.8, you betcha. So 19.8 squared. And then what's going to be my a squared? You bet. And then what am I going to put for b squared? Yeah, I'm just going to put b squared there because I don't know what that is. So my next step here is, what do you think? What do you think my next step here would be, Aiden? Putting you on the spot.
Squaring the numbers.
Squaring the numbers, you betcha. If you wanted, you could eventually skip this step if you understand what's going on. You could give me the answer from this point. I don't understand how you got it, but you're right. I'm going to square those out. So I'm going to take 10.6. I'm going to square it. And that's going to give me 112.36. And that's all plus b squared. And that's equal to 19.8 squared, which is going to be like 392. 392.04. Cool. So what's my next step here, Austin? Oh, Austin, what's my next step? If you had to guess. What am I trying to find here? I'm trying to find b squared right now, right? I'm trying to find b squared. More specifically, I'm trying to find b. So that means I need to get it by itself, don't I? I need to get rid of this to get it by itself, don't I? So I'm going to subtract this 112 from both sides. This is going to get canceled out. So I'm just left with b squared. And then this is going to be 392.4. Sorry, 0.04 minus 112.36. Understand how we got there? No, that's fine. So I'm trying. So you said it yourself. I'm trying to figure out what b squared is, right? But I can't. I needed to tell me. I needed to tell me b squared is equal to this. This is the answer for b squared, but it's not because I got this thing in the way. So what I need to do is I need to get rid of this thing entirely. So what I'm going to do is I'm going to take this away from this side. It's gone. But to do that, I also got to take it away from this right side. So I'm taking it away from both sides. So if you ever seen like one of those like scales before, if I let's imagine I had like 10 sugar cubes on each side of a scale. If I took away 2 from each side, it's still balanced, isn't it? Yeah. So harder numbers, but I'm taking away 112.36 sugar cubes from both sides, essentially. And so then that's going to give me b squared is equal to so 392.04 minus 112.36. It's equal to 279.68. Thank you. But so going back to it, Austin, I'm not just trying to find what b squared is. I'm trying to find what b is. Because that's what this is, right? This is technically b, and b. So where was it? This thing here is technically b, but this whole thing here is b squared. I don't care what b squared is because I just want to figure out how long this line is here. So what I need to do is I need to take these square roots of both things. By taking the square root of b squared, I'm just going to be left with just b. And then taking the square root of this thing, 279.68, I'm going to be left with 16.72.
But on the answer sheet, it's only one decimal.
Oh, whoops, that was past me doing one decimal. Okay. Cool, so everyone has that written down? No one is saying no. I'm gonna scroll up here. So Pythagoras and like trig, which is like sine, cosine, tangent. Those are two tools that you can make really complicated questions with. So now what I want to do is I want to go up to question. I think I wanted to skip this one, did I? Yeah, okay, I wanted to skip question 2. For now, I wanted to go to question 3, which is on page 8 or page 6. Thank you.
There's not one, okay.
Is it on there? Okay, just make sure it's printed right. Okay, so it should be on page 6 here. We're skipping question 2. We're just going to skip question 2 because I made it wrong straight up. So what we have here is we have a piece of plywood that's being cut into the shape below, into this shape. We want to calculate the dimensions of the plywood. The dimensions is the fancy way of saying I want to find the perimeter. I want to figure out how long each one of these 4 sides is. That's what it's asking us to do here, right? Now, does anyone know so this is a complex shape. We called it something else though. It also started with a C. You remember what that was? This is a compound shape. This is a bunch of simple shapes that are turned into a more complex one. So a really good idea here to do is, why don't I turn these into simpler shapes? And if I do that, I can see that I actually have here is I have a rectangle and I have a triangle here, right?
Or 2 triangles.
Or 2 triangles.
Have to just,
Oh, I see what you're saying. Yeah, I see what you're doing there. Yeah. Sorry.
maybe straight, right? Maybe square.
Oh, so I like where your head's going. So how can you think it's a square? Not we can't just say, oh, it looks like a square. It tells us
When you
something.
make the line straight, it can be square.
Oh, like these 2 things here, or this thing here. So we think it might be a square, but we don't know for sure. But it is a square, but not for the reason you think of. Not just because it looks like a square. The pictures could be misleading sometimes. But this is a square because you see these little notches up here? This means it's the same length, right? So this thing over here is 6 feet. I see this thing over here is 6 feet as well. Now, if the top of a rectangle is 6 foot and the side of a rectangle is 6 foot, the whole thing's a square, right? Because that means this line over here, this dash, is also 6 feet. That means this line over here is also going to be 6 feet. So we actually have a square and a triangle here. So again, I want to remind ourselves, what's this question actually asking us to find?
Dimension.
The dimensions, the perimeters of it, right? So we can make a little equation out of that. So I always recommend you do this at the start of every single thing, make a little equation for it. What this technically is asking us, and if you don't understand where I'm getting this from, please let me know. If I say AB, what that technically means, that is the length between point A, the little corner A, and the corner B. What's the length of AB? 6 feet, right? So technically, this is asking you to do AB plus BC plus CD plus, not DA, AD. Does that make sense where I got those 4 things from? AD. I don't put DA, I put AD. I always put the thing that comes in the alphabet first. And I promise not to put like Q's and U's and W's and stuff in there because I have to repeat the alphabet when it comes to that stuff. Okay. I'm gonna want you to leave a couple lines after this. So like, don't draw this line, but leave some space. Leave some space. We're gonna fill this in later, okay? So first off, let's put what I know. Do I know how big AB is? How long it is, sorry? How long is it? 6 feet. Do I know how big BC is? I know it's 6 feet, you're right. Do I know how big CD is? I don't. I know how big this line is, but I don't know how big all of it is. So I'm gonna leave that blank now. Do I know how big AD is? No. Some people might say it's 6. It's not. The 6 is the height of this. It's not actually that. But I know some of it. So I need to figure, now what I actually know is I need to figure out what these two things are. And then I have my answer, right? It's just 6 plus 6 plus however long this is, plus however long this is. That's what it's asking me to do. So what I'm going to do is I'm going to go over and I'm going to put, why don't we figure out what CD is? But so this line right here, you don't have to draw this line. You don't have to draw this line. So here's what I know about this line though. I know that it is, this part right here is 6 feet, right? So all I actually need to do is I need to figure out how long this little part here is. I only need to figure out how long this little line is.
So we do the. I was trying to do that.
You're getting on the right track. So what I'm actually going to do is I'm actually going to add another label in here. I'm going to say this little point right here, I'm going to say is E. And so this whole line here is CD, right? But I added a little E here. I'm gonna erase that and make it a little bit bigger. Text E. And you're gonna see why I labeled this in a second. You could do it without doing this. It's just gonna make it a little easier to organize. So technically, what CD is, the line CD is really just, it's CE, the 6 feet, plus this little part here, this DE. So it's really just going to be 6 plus DE. Making sense? Cool. So let's figure out what DE is. So what we have here is we have ourselves, you do not need to draw this triangle. I'm just doing it for reference. Do not draw this. You may run out of space otherwise. So I'm just putting this here. So I have this triangle here. That's what I have. I've just taken this little triangle here because I'm trying to figure out what DE is. So this is D, this is E, this is A. So I know that I have an angle of 68 degrees. I know it's a right angle, and I know the length of this side, which is what, Austin? 6. Yeah, 6 feet. You betcha. So here's what I have. What am I trying to find here? The length of DE. I don't know what it is. I'm just going to put in, like, you could put whatever you want. I'm going to put an X because that's the one most people see, because that's what I'm trying to find. So here's what I know I have. I know I have an angle, and I know I have a side, and I'm trying to find a second side. Which of the formulas do you think I'm going to use for this? Or sorry, do you think I'm going to use Pythagoras, or do you think I'm going to use a trig function? We don't need to know which trig function yet. Okay, so you're thinking trig, and so let's find out if it's tan. So this is my angle here. This is my hypotenuse. This is my opposite. This is my adjacent, right? So here's what I know. I know what the opposite is, and I'm trying to find the adjacent, and I have an angle. It is going to be tangent. So what I'm going to do is I'm going to take the tangent of the angle. So tangent of theta. Is that big enough? Is equal to opposite over adjacent. So does that make sense how I suddenly went from addend to tangent? Because I've recognized that I have I have a side of a triangle. I'm trying to find a second side of a triangle, and I have an angle to do it with. I don't have two sides of a triangle, so I can't use two sides to find a third. So I have to default to trig. So I'm using tangent here. So now I'm just going to substitute stuff in. Now, what's different about this question though is, oh, sorry,
You only have one number.
I only have one side, but what I do have is I do have an angle. I do have 68 degrees. And I do know my opposite is 6, but I don't know what my adjacent is. So you could either put this as X or you could put it as A, whatever works for you. I'm going to put it as A just because we know that this is the adjacent side. So all I've done is I've substituted this in. So what's my end goal? I want something to equal my answer here. What's the something? Not quite 10. I'm trying to find, there's only one missing piece here, right?
Yeah.
Adjacent. So my end goal here, don't write this down. My end goal is it's going to be A adjacent is equal to whatever my answer is. That's my end goal of this. So what I have here is I have an equation that I need to be able to solve. So I need to get A by itself. Well, right now, A is stuck down here. So what I'm going to do, I'll swap the blue for this, is I know I need to do something to this equation to both sides of it, right? Think of a scale, right? Think of a scale. We need to do whatever we do to one side, we have to do to the other side. So what I'm going to do is I want to get A by itself. Right now it's stuck on the bottom of a fraction. I'm going to times everything by A. What's going to happen with these two A's over here? Cancel out, you bet. So on my right side, I'm just going to be left with it's equal to 6. That's what it is, equal to 6. These two A's cancel each other out. I'm just left with 6. This is technically 6 over 1. We're super lazy mathematicians. 6. So that's on my right side. On my left side, I'm going to have tangent of 68 degrees times what? Times A, right? Because I'm timesing it the whole side by A. So I'm going to have tangent of 68 degrees, and the whole thing is times by A. That's another reason why I didn't use X. Cool. But remember, what was my goal? What am I trying to get by itself? A. So my goal here is I'm just going to have A equals my answer. And now I'm getting close to doing that, but there's something in the way. What do I need to get rid of on this left side? Tangent of 68. Yeah, you betcha. So what I'm going to do is I'm going to divide both sides. Blue. Divide both sides by tangent of 68. You don't need to write this like these little steps here if you don't want to, if you understand what's happened, but if you're not sure, really good idea. I'm just going to divide by 10 on this left side for space. So all of a sudden, I'm going to have A is equal to 6, all divided by tangent of 68 degrees. So here's where the calculators get a little bit stupid, is one way to put it. So first off, I've figured out what I have A equals something, right? I have met my goal. I just now need to turn this into a number that makes sense. So A is going to be equal to my answer. So now I need to use my calculator. So fraction 6 by tangent of 68. So now some of you might be asking the question, but you just said you can't divide by tangent. You just said you can't do that, right? How come I'm doing it here? This will give me the answer now. How come I can't do it? It's because I'm not dividing by tangent. I'm dividing by tangent of 68, which is equal to something. It's equal to something. So that's the difference here. You can't divide by tangent by itself. That's what we were doing before. We just got rid of the tangent only. We kept the angle in there. Now I'm not dividing by tangent. I'm dividing by tangent of an angle, which is equal to something. So this whole thing is going to be 6 over tangent of 68. And that gives me my answer, which is 2.42. 2.42 feet. Okay. So this is an important thing. I'm going to underline it or circle it, or I'm going to do something with it so it stands out, because I just spent a lot of work to get this thing. But I don't want to lose sight of our original goal. Why did we find this in the first place? What is this? This 2.42 feet. Where does that go?
The little tiny spot.
This spot here, you bet. That's what that is. So this little thing here, all that work was for this. That's what all that freaking work was for, to figure out that this thing here is 2.42. But now I know I have half of my puzzle solved. I know what CD is now. What's CD? Going all the way up to the top here. What is this CD? Sorry? Not 2.4. 2.42 plus the 6, which is 8.42. Right? So it's making sense how come I just pulled 8.42 out of the air? Makes sense why I got that? Because it's that 6, which we know, plus that part we don't know. And all of a sudden, I know the length of this full line here. Cool. Last piece of the puzzle is going to be, I'm going to erase this. So I have my side here. I hope you guys didn't write that down. I told you not to write that down. The last piece of my puzzle is I need to figure out what AD is. So how come you're thinking Pythagorean theorem?
Because it's a triangle, then you know the height of.
2.24 or 14.
Yeah, you're right, Aiden. I know I have a triangle. I'm trying to find a missing side. I know 2 of those 3 sides. I can use Pythagoras. I could also use a trig function there, but you have options now. I don't care which one you use, but I'm just going to use Pythagoras just to mix it up. So if I want to try and figure out what this thing here is, so same thing. I'm going to draw that little tiny triangle. I know that this length here is 2.42. I know this length here is 6, and this is what I'm trying to figure out, right? So I have 2 sides of a triangle. I'm trying to find a third triangle. Oh, that's Pythagoras, which is a squared plus b squared is equal to c squared. Those are not very good 2s. The hardest part is usually going to be figuring out which thing I need to do. It's what's my next step. It's not that it's super hard math. We've already done this stuff. It's when we combine it together that it gets, ugh. Okay. So what is my c squared here? We don't know it. You're right. So I'm going to leave it as c. But I do know a and b. I know it's 2.42 squared plus 6 squared. And so if I plug that in my calculator, 2.42 squared plus 6 squared, 41, 20, yeah, 0.86, you bet, is equal to c squared. I don't care what c squared is. I care what c is though, right? So what do I have to do here? Take the square root of both sides, right? Square root, square root. Someone tell me, why am I taking the square root of c squared? How does that give me c? Okay, I'm gonna finish this and then I'm gonna explain why. So I'm gonna take the square root of 41.68, or sorry, 0.86. Square root of 41.86 is 6.47. So 6.47 is C. It's not just C though, it is the length of this line. Cool. So now I have all the pieces of the puzzle, right? This is why we left space at the top.
So there's not more steps to this?
Nope. Not well, I mean, yes, no. But so now I had, this question originally asked me, find the length of all sides and add them up. That's what it asked me.
So we just add them all together.
Yeah, now we just add all of our answers together. So 6 plus 6 plus 8.42 plus 6.47. That's the length of all 4 sides. What does that give me as an answer? 26.89 feet, right? And I'm just going to circle that because that's my final answer. So again, you can take like simpler questions and add them together and it turns into a mess. That's why I really recommend make a formula on the top. It's going to be really, really huge to do. So everyone has that stuff down? Oh, still raining? Okay. Okay, everyone's good. So I want to go back to this thing here, the c squared. I'm going to use a different color. I'm going to use a, come on. I'm going to use blue for this. So this thing right here, how does taking the square root of c squared give us c? Because I told you so isn't like, I mean, yes, it's an answer, but not like the answer. So I want to go into what this is actually saying here. So if I was to give you like 5 squared, you know that this is technically 5 times 5, right? Which is technically 25. If I were to take a line here, this is 5, right? If I was to square that, what I'm technically doing is I'm taking that and all of a sudden I'm taking 5 of these things together. I'm turning this into a square. That's why we call it squared. I have 25 little squares here, right? So when we square something, it kind of makes some sense, like visually. Taking the square root of something is a little bit harder. What taking the square root of is basically saying, I'm going to give you a bunch of blocks arranged in a square, and I want you to figure out how long one of those sides are. Trying to find this thing here. So this is basically taking the square root of 25, because there's 25 blocks here. And the square root of 25 is going to give you 5. So that's technically like what it's doing. It's asking you to like find out the length of this side. But again, like how come we're taking the square root of it, like c squared? That's where this thing kind of comes in play, right? My gosh, I'm going to erase a whole bunch of stuff here. Because when we've already established that this c squared like is just all these this blocks plus this blocks added up, right? We've already like established that. But what we're actually doing here, when we're taking the other thing, when we're taking that square root, we're trying to figure out the length of this side. Because if this is true, if I can take these 9 blocks and these 16 blocks, it's always going to equal this. The opposite's kind of true as well. I can take the square root of this to get back to this little triangle here. Maybe I'll show you a video tomorrow, but there's a really nice thing of like water that demonstrates this. I hope that made sense. I know it's kind of confusing. It's very abstract in a sense. But that's why we're taking the square root of this is because this whole thing here, if I told you this side is C and this side is C, this whole thing here is technically C squared. And so taking the square root of it, instead of like 25 here, we're just trying to figure out how long is this line? Well, it's just C long because it's C times C gives C squared. Taking the root of that, find out just what the length of one side is, just going to leave you a C there. I know that's confusing and abstract and very rushed. We just don't have a lot of time to fully go into it. I'm going to erase all that stuff. Why don't we take our break now? We've just gone through a lot of math. Let's take our 15-minute break now, maybe instead. So we'll come back together at 2 o'clock. So what I'm actually going to get you guys to do now is I'm going to just get you to head to page 9 and just start from there. Just to take the time now to do your practice. I'm going to come check up on progress in a couple minutes. This one up here?
No, 3, 9, 9.
Ooh, on how to, okay, yeah, on how to solve it?
Well, I figured out one side, but I just don't know.
So let's break that down then. So no, that's good. That's good. Yeah. So the ultimate goal here is we're trying to find the length of this. That's the ultimate goal that we have. We're trying to find the length of that hypotenuse of it. But to do that, we need to get the length of this line, don't we? Because then we can use Pythagoras, right? So we need to get the length of this line. And to do that, we need to use this little triangle on the right. Because in this triangle on the right, we know the angle. We know the angle and we know the length of one side. And we can use that to find the length of this side. So we can use an angle and a length to find another length. So you're going to use a I'm just going to call this one triangle A and this one triangle B. You're going to use triangle A to find the length of this side, and then you're going to use that to get your answer in triangle B. So it's sorry?
Yeah, I'd like.
I know.
I don't think I could, guys up numbers like way too big.
Hmm.
If 33, 19, 52, then that kind of stuff.
So I'll come take a look then. You have the way to check your answers, but I'll come take a look there.
Oh,
Yeah. You have the cheat sheet. It only tells you the answer. It doesn't tell you like how to get to it.
Oh,
No, okay, I'll come take a look in a bit. You know what? How about we go to just straight to page 13 then? Just a way to just to kind of start off then. So maybe head to page 13 unless you're feeling really confident.
13?
Yeah, 13.
I don't feel confident.
And that's fine because we kind of had to power through it for the sake of time. So that's okay. But I don't want you guys to feel like lost in the wind. So maybe head to page 13 instead. And what I'll probably do is for some of these, I might make a video as well for some of those other questions, those harder ones. So anyway, head to 13. I'll make my way around in a couple minutes then and see how we're doing. And I'll if you want, Kim, I can come help you with that other question, unless you just want to leave it for now.
I want to do it.
Okay. I'll come over there in exactly 1 minute then. All right, let's take a look at that question. Okay. No. So here's what I need. I honestly when I first when I first started, I literally so full of my hand every day for a week. Way back when I was like, I don't even know, 16 or something. Remember the teacher? Perfect. Okay, so now we can substitute that, right? So for opposite, we go.
Yeah, and that's equal to opposite, which is we got the original. That's all over. And then these are just. Negative offset, that's it.
So 10, that's 10.
Can be considered five.
Not second one,
Not a second one, right? Because that's only what we had said.
times 10,
Yeah, so can be considered five times.
so 15,
40 something.
2.
Sure. So now we know like this. All of a sudden, we have 2 lengths, which I have to. Oh, so, oh, sorry, go first. So 13. Okay, 13, that's not line, right? So now what I'm trying to do, the question asks us for X.
Okay, so 35, okay, now,
Yeah, yeah. So now you need to say.
okay.
Just, that side. Oh, okay, so I'm just looking at this one here. So you messed up. You solved the right process. Yes, that's the wrong number. Oh, okay, that really just happened. So this one over here is our opposite, and this is our adjacent side. So you did. So this one should be over 19 instead of 19.
Oh,
yeah, yeah.
So
But the answer,
when I put that into the calculator, I still zero.
ooh, I see what you're saying. So
You can move it.
So this is technically just going to be, if it won't be, yeah. Then you get pretty much close, because you have the right process. So that's over 19, tangent 35. Sorry, tangent 35 equals 100.
Yeah.
So I'm trying to get all whites.
Yeah.
Okay, so I need to get rid of this 19 here.
Oh, all right.
So I got this times both sides.
Okay.
That makes sense. Yeah. Yeah, so that's not just on the O, and then on this side, I'm gonna have 19. Okay, so plug in your calculator now, that should give you, it'll give you a close answer.
Yeah,
But,
that's pretty close. And then what's that? Am I doing good on this one so far?
so you're trying to find this thing.
Yeah. I know the opposite. I just need the edges.
Yeah, you just need the base, the one.
Yeah.
Okay, so you found.
Yeah, it is. I'm just thinking.
Figure that out. Just stop. Oh, wait, no, I thought I had it. I thought I had it.
It's like
The
I do that angle.
Yeah.
You need that.
If we yes.
Okay.
Like, I'm going near like this close, right? It's probably 60, but this 36. That's this.
Yeah.
I gotta go back and look at my
Oh,
stuff.
yeah, I can go on to the next one.
Yeah, I gotta look at my stuff there. I just. Oh, thank you. Any questions?
Yeah.
Oh, this one here? Yeah, so you're right, so this one's gonna be tangent, so we're trying to find the this, right? So we need to use Pythagoras, because we figure out this. We have 2 or 3 sides, but we need to get this side first. So we need this triangle. So what we need to do is we need to, and this is opposite, this is opposite, this is adjacent. I have an adjacent side, I'm trying to figure out what the opposite is. So yeah, you're right. I didn't. So opposite over adjacent, right? 3, so my opposite, so my adjacent. So I need to try and do both sides. So tell me. To do that. Not quite, not divided by 19, I'm going to times the sides. Because that is going to cancel these 2 things out. Times tangent. 4 tangents times. You can get equals in. So you put, oh, so we don't need that, we're just gonna use, so just see it 19 times 10 equals, and that's 13.3. And that's that side. So when we have that triangle, so if we cover up that triangle. It's not a problem. We would, because it only has 2 sides. You got it.
So this.
So 4,
So is this way or this way?
there's technically 3 triangles in it, skip 4, because I think I left out some important information. And as it stands, I believe is unsolvable.
Okay.
Yes. I think I gave you guys.
Degrees, what is?
So what I got 54 degrees. How the heck did I
It
get?
would be 8.
So I need a length of another side of that little triangle left to figure it out. Ultimately.
Well, what is this script line?
Oh, yeah, and I think I might have just figured it out. Trying to figure the trickery I did there.
I'm gonna try and solve it really quickly. Okay. Let me try and solve that.
So if you know. Never mind. But what did you put your hypotenuse or the line there?
This is question 4. I think I just made an unsolvable one in there. Oh, shoot, am I still recording?